Magnetic fields exert force on things that are magnetized, like compass needles. Magnetic fields also exert force on moving charged particles, like ions.
Magnetic fields have direction. The fields point from north poles to south poles. What does that mean?
Think about the last time you played with refrigerator magnets. Some sides stuck together and others wouldn't, right? That's because of the north and south poles of the magnets and the magnetic fields the magnets create.
Here are the magnets. They have north and south poles. The poles are concentrated areas of magnetic field.
So that still doesn't really tell you how magnetic force works. Basically, we find that opposite magnetic poles attract, while similar poles repel. Moving charged particles are deflected by magnetic fields.
We can draw lines like this to show the direction of the refrigerator magnet's magnetic field. See, the field points from the north poles of the magnets to the south poles. If you stick the magnets together, touching the north and the south poles together, everything's fine, because the magnetic field still points from north to south. But if you try to stick the north pole to the north pole, the magnets won't stick. The magnetic forces are pushing against each other and won't let the magnets stick.
When we draw a picture of a magnet and a magnetic field, the lines that we draw showing the direction of the field are called field lines.
So by now, I bet you're wondering, the Earth has a magnetic field. Where did that come from? Well, this is where everything comes back together again.
The inner and outer cores of the Earth are made of conductive metals. The inner and outer cores spin at different speeds. If you remember from a few minutes ago, we said that when a conductive metal is inside another conductive metal and they spin at different speeds, electricity and a magnetic field are created. So, that's exactly what's happening at the core of the Earth. The solid inner core and the liquid outer core spin at different speeds and create electricity and magnetism. The electricity doesn't affect us much. It just keeps to itself down in the core. But boy, does the magnetism affect us.
On Earth, we use the magnetic field to help us get around. We make compasses by suspending a small magnet in some water. The north and south poles of the magnet align with the north and south poles of the Earth's magnetic field. We put a little arrow on the part of the magnet that points north, and from then on, we always know which way is north.